Hello, Assalamu alaikum students, how are you? Today we will discuss frequency modulation and I'm your instructor Muhammad Ali Musawir. So let's start it. So first of all, let's say what is a frequency modulation? Frequency modulation is actually a process in which the frequency of the carrier wave changes according to the instantaneous amplitude of the message signal. So this is called a frequency modulation. Previously in the amplitude modulation we have seen that the amplitude of the carrier signal changes according to the instantaneous amplitude of the message signal. But here actually in frequency modulation we have the change of frequency of carrier signal based on the instantaneous amplitude of the message signal. This is frequency modulation. We have different types to produce the frequency modulation, to do frequency modulation. We can do this by direct frequency modulation technique. In this, what we have to use the voltage controlled oscillator. It is usually seen that you can say that usually we do this with the help of ICs, alright. And in what case we have to use it, we will use it. It is actually a simpler, you can say simpler thing. We can produce the frequency modulation in a low frequency range, alright. Similarly, we have indirect frequency modulation technique in which we can convert the phase modulation into frequency modulation. In this we can deal with higher frequencies and also we will have a stable frequency. Similarly, we have another modulation type. It is called reactance modulator. In this we use the local carrier oscillator. It is transistor based. Similarly, we have other things, and also we can do the frequency modulation by using the phase locked loop based frequency modulation. You can say that majorly phase locked loop is used in demodulation of the frequency of the FM signal, but you can also use the PLL, the phase lock loop, in the modulation of this wave. And you can say that it is you can say that it is the most precise one, it is the most stable one. So we generally use PLL in the demodulation, and in the modulation. In this video we will discuss the direct FM type. Alright, so how we can do the modulation, the frequency modulation. This block diagram is actually of direct frequency modulation transmitter. Let's discuss it. Here, alright. Here, from the microphone, we will have our audio signal, and then we will process it in the pre-amplifier stage, means where we will do some filtration, we will amplify it, okay, and then we will have our modulator stage, the block of modulator. In this modulator, we will have two inputs. First of all, the amplified audio signal, and then from the radio frequency carrier signal. You can say that this is the carrier signal, and after modulation of it, we will have a modulated RF signal. What actually happens here? Wait a minute. Okay, so what actually happens here? The amplitude changes the frequency of this local oscillator wave. Here the wave comes, and according to the amplitude of this audio signal, the frequency varies. Which frequency? The frequency of this locally produced oscillator. The frequency of this wave changes on based on the amplitude of audio signal. This is called the modulation, and as a result we will have a modulated radio frequency signal, and then we will amplify it. After amplifying, we will transmit it through the antenna. This is actually the frequency modulation, and it is what it is, the direct frequency modulation transmitter type. All right. Similarly, in the demodulation, in the frequency demodulation, we will have different types. In the first type, it is the slope detector form, in which we will convert the frequency modulation, the FM signal, into amplitude modulation signal, AM signal, with the help of some diodes, etc. Okay, and it is a very basic case. You can say if we just need a very basic thing to understand, just you can say in the labs or in the experiment to just understand, so we can do this. Okay, but it is not efficient way. Sorry, wait a minute. Yes, here it is. So it is not the efficient way. So we have other methods too. Here we have the balanced slope. Okay, we will not discuss it, but we will discuss here the phase lock loop system. So it is what actually a phase lock loop is a thing in which the phase, the angle of, you can say, the angle of the locally produced wave, or you can say that the change of the angle, the change of the phase will decide that what will be the amplitude of the wave. Okay, you can understand this thing in that way, that in the modulation, what happens in the modulation, here in the modulation, the frequency changes on the based on the amplitude of the audio signal. But in demodulation, what will happen? In demodulation, the amplitude will change according to the change in frequency. Let me repeat again. In modulation, the frequency of this locally produced wave will change on based on the amplitude of this audio signal. But in demodulation, the amplitude will change based on the difference on the frequency modulated signal. Okay, sorry, wait a minute. Okay, so if we discuss the block diagram of this frequency demodulation, you can see it is a phase lock looped frequency diagram. And this, what is it? This is the, you can say, the IC, the demodulation system, or you can say this whole thing can be built inside an IC. So here is the demodulation. What this block will do? You can say that this block will generate a voltage based on the difference of the input signal and here the, you can say, the reversed, or you can say the signal that is back through in this phase detector. So the signal comes here, it passes through a low pass filter, it is the output one. Then after amplification, you can say after amplification it passes through a voltage control oscillator. You can assume that here a signal of, let's say, 1 volt is coming here. Okay, and it passes through an amplifier, and after it 1 volt, or you can say after amplification it can be 2 volts. So 2 volts will produce uh, a wave. It can be a sinusoidal wave. So in general you can say that the 2 volt will produce a sinusoidal wave of a known frequency, and it will go there. So let's suppose that at this point the frequency is about 1 megahertz, let's say, and here the frequency that is coming from the voltage control oscillator, it is 99 kilohertz. 999 kilohertz. So there is a gap of, you can say, 1 kilohertz. So that difference of frequency will generate a voltage. Okay, so that difference of frequency will generate a voltage, and the difference will be our point, will be our output that is used in, you can say, in the detection of the amplitude. If the difference of these two frequencies is higher, the output voltage will be higher. If it is low, the output voltage will be low. So in this case we will have a phase lock loop, sorry, in which uh, the output goes back in the first place, and here we have a loop. All right, if we compare the signal, analysis, it is the message signal, and here we have its frequency spectrum. Okay, a frequency of 1 kilohertz sinusoidal wave. Here we have a carrier wave, and it is about 100 kilohertz. Okay, in the modulated signal, what will happen? In the modulated signal, you can say that where we have the lowest amplitude, our frequency will be low. If we have the higher amplitude, our frequency will be high. In this case, the amplitude will change the frequency of our carrier signal, and in the frequency domain it looks like this. Alright, similarly, if we talk about the demodulation, where we have the low frequency, we will obtain a low amplitude. Alright, if we have the higher frequency, like here, we will have the higher amplitude. So what actually happening here, sorry, let me do it again. Yes, never mind, let's see from there here. So what actually happening here, in the modulation, the amplitude is changing the frequency of the carrier wave, but in demodulation the frequency is changing the amplitude of the wave. Alright, so this is what modulation and demodulation of frequency. Alright, now let's see some practical things so that we can understand it in much detail.
The upper signal is message and the lower signal is carrier. Now this is the modulated wave that we have. The upper one is the message signal and the lower one is the modulated signal. You can see where the amplitude of message is high, we have our higher frequency, and where the amplitude is low of message signal, the frequency of the modulated wave is low. So the frequency change is totally dependent on the amplitude of that message signal. Okay, you can see here clearly that at this point the amplitude is low, so the frequency will be minimal. And the places where the frequency is high, it shows that at that point the amplitude will be high. Alright, now let's talk about the demodulation. The lower wave is our original wave, and the upper wave is our demodulated wave, means the original message signal and the extracted demodulated message signal. All right, so the upper signal, you can say that it has some delay as compared to the original signal because it passes through components, and you can see the frequency, the original frequency and the demodulated frequency, there is a little difference, but approximately equal. Also, you can see the peak to peak voltages, okay, that are, you can say, near, or you can say somehow very near to each other. All right, so this is the demodulation and modulation of frequency we have in this video. Thank you.